Okay, maybe now is better, right? So the work that I conducted here in Bologna under the supervision of Professor Di Pellegrino and Dr. Starita. And the present talk and the two that will follow will discuss different ways of investigating the role of the motor system in aversive conditioning. But what is aversive conditioning? Already mentioned it this morning, but this is just a small recap. So it's a simple form of associative learning by which an intrinsically neutral stimulus acquires an aversive value by repeated pairing with an aversive outcome. For example, the presentation, if the presentation of a colored dot is paired with an aversive shock, that is an unconditioned stimulus, then it induces a fear response. As a result of this pairing, the colored dot acquires an aversive value by anticipating a possible threatening event, and fear learning then takes place. So that the sole presentation of the conditioned stimulus can induce a conditioned response that can be measured by changes in psychophysiological responses, in subjective experience and overt behavior. And as we have seen through Pavlovian conditioning, it is possible to learn that a stimulus can predict an imminent danger. And thus, this helps us to enable us to prepare for it. And in this situation, as suggested by previous research, the response of our organism involves general preparatory processes, as well as more specific preparatory processes that are linked to the type of threat that we have to face. And whereas the role of general preparatory processes measured through autonomic responses have been extensively investigated, little research and little attention has been put into the role of the motor system in anticipation of threat. And in order to study the role of the human motor system in this process, we performed a study that I'm going to present. And the aim of this study is to characterize changes in motor excitability when learning to predict the delivery of an aversive shock in a paradigm of Pavlovian aversive conditioning. And in this learning procedure, participants learn to identify two stimuli as dangerous and one stimulus as neutral or safe. So two colored dots, as you can see here, ended with an aversive shock that could be administered over the left or the right arm, whereas a third stimulus, a third color, was never paired with shock. So these are called CS pluses, and this is CS minus. And shock intensity was individually calibrated. Therefore, it was reported as to be highly unpleasant, but not painful. We tested 28 right-handed participants, and we measured the electrodermal activity from the left hand to characterize changes in psychophysiological responses during the presentation of conditioned stimuli that could be associated with a different aversive value. And to investigate the role of motor responses, we instead used transcranial magnetic stimulation, as Lara already introduced, delivered over the left primary motor cortex, and motor evoked potentials were elicited at the level of the first dorsal interosseous muscle of the right hand and the extensor carpi radiali muscle of the right forearm. And the peak-to-peak amplitude of the motor evoked potential is considered as a measure of corticospinal excitability. And in a typical trial, the stimulus was presented on the screen for 4.5 seconds. in this time, skin conductance responses was acquired. Then the TMS pulse was delivered and MEPs were elicited from the target muscles. And following 60 milliseconds from TMS in designated trials, the shock was delivered either on the left or on the right arm, depending on the type of stimulus that was presented. And it is important to consider that in order to study the role of the motor system in anticipation of threat, TMS was always acquired, TMS was always delivered, and MEPs were always acquired before the delivery of shock. And in addition, in this task, participants had just the task to carefully observe the stimuli presented on a screen, but they did not have to perform any action. At the end of the task, participants were requested to explicitly evaluate the different stimuli, and they rated the conditioned stimuli as more unpleasant than, than the neutral stimulus. As well, they judged, they correctly reported the association between each CS and the laterality of the shock, as can be seen from both from the expectancy and contingency graphs. Therefore, it appears that the learning procedure was successful. But going into the psychophysiological results, what we found is that we found a greater skin conductance response in response to the CS pluses, so the conditioned stimuli, compared to the CS minus. And it is important to note that this increase in response was found regardless of the side of the predicted shock. Instead, as concerned the motor excitability results, what we found is that we found a significant decrease in the MEP amplitude for MEPs acquired during the presentation of a stimulus anticipating a shock delivered on the side congruent on the right side compared to the neutral stimulus or the stimulus associated with the left shock. I hope this is clear. So MEP, in this effect of inhibition, lateralized inhibition, was more pronounced for the FDI muscle, as you can see here in white. And looking at the learning performance over the trials during the learning procedure using these cumulative sums, we can appreciate that here as well, we can see this increase in skin conductance responses for CS pluses compared to the CS minus. And in motor terms, we can see clearly this inhibitory modulation for the FDI muscle when a stimulus associated with a right shock was presented compared to the other stimulus. And this kind of trend, is, again, was more pronounced for the FDI than the ACR muscle. And we replicated these results in a following experiment in which we explored the muscle specificity effect of this inhibitory modulation. And in this second experiment here below, we basically used the very same procedure of the previous experiment, but we changed the position in which the shock was delivered. So as we can see here in the previous experiment, shock was delivered over the right or left forearm nearby the ECR muscle. Instead, in the second experiment, we moved the shock that was delivered over the left or right hand nearby the FDI muscle. And what happens here in the second experiment, still we can see in terms of skin conductance responses, this increase for CS pluses than the CS minus. And here for MEPs, we confirm this kind of inhibitory modulation for the FDI muscle when stimulus associated with a right shock was presented compared to the other stimuli. But as you can see here, as regards the ECR muscle, it appears that it does not distinguish between the three stimuli anymore. So we confirm this lateralized inhibitory modulation for the FDI muscle. To summarize then, we found increased skin conductors responses for conditioned stimuli compared to the neutral stimuli, showing a non-lateralized response in anticipation of aversive shock. And for the FDI muscle, we found a lateralized inhibitory modulation in corticospinal excitability in anticipation of side-congruent aversive shock. Overall, we have demonstrated the motor system involvement in threat prediction, and we showed how motor and autonomic responses are differently modulated by threat of shock, and also that they show a different degrees of lateralization. That is, a different degrees of specificity according to the characteristic of the aversive shock. Indeed, we have found more general and non-specific preparatory processes taking place in response to danger that can be reflected by the activity of the autonomic responses. On the other hand, our inhibitory results suggesting a lateralized inhibitory response for corticospinal excitability when we are presented with a stimulus that anticipates a shock that is going to be delivered on the same arm, suggests the activity of a more specific preparatory process that takes into consideration the characteristic, the sensory characteristic of the predicted shock, like its position and lateralized presentation. And overall, these results highlight the existence of multiple and dissociable learning systems in aversive conditioning that show a different degrees of lateralization in anticipation of an aversive stimulus. I thank you everyone for the attention, and I will leave the space for the next presentation of the same line for my colleagues.
So thank you. Very nice photos. Really appreciate it. Maybe so I'm not very frightened in this pain literature, but I think that this is the first evidence that you can get anticipatory responses in pain or let's say aversive. It's not pain, and I think that needs several agents in neuroimaging back to the early work of Pogro in 1998, so very seminal work on that, but there's no physiological evidence in TMS. A lot of studies that can show that you get similar inhibition when you perceive a person stimulus, but no, not so. First of all, I really appreciate that you can get this in anticipation. TMS and motor potential. I was just wondering whether, so how did you interpret this response? So in terms of an anticipation of withdrawal reflex, for example, or like hoping with some, I don't know, some potentially not useful complacent, let's say, stimulus, and so you have to freeze because of you are just preparing to cope with that. So I want if this is the case, then it would be a good idea to try to perform for more optimal muscle, because
Yeah, this is
like an inhibition of vital components of the heart, but a facilitation more broad. First. Second, I mean, if I understand correctly, stimulus, and after
4.5 seconds.
yeah,
Approximately.
I think you
Yeah.
find the station of the TMS pulse, but overall it's quite predictable.
Yes.
So, and I'm just wondering whether maybe just
No, no.
you went the-
No, no, yeah, I have.
So I was just wondering whether if you expect that this response would be highly related to the temporal ability of the stimulus, or you would expect any more not transient but more tonic rates, which
Yeah.
is in addition.
Okay, so I will try to, yeah. So the big question is what is this for? Yeah, and this is kind of a hard question. We are discussing it for a while, and still it is a kind of an open thing in the interpretation of this data. For sure, this kind of inhibitory activity, as you mentioned, was already found in response of an aversive stimulus. So when pain or aversive stimulation was delivered, after following it just already after 50 milliseconds till almost several milliseconds, you can actually measure this inhibitory activity. And the nice thing here is that we found the same results in anticipation. So it is possible that the same kind of mechanism are involved in both situations. Surely here could be a kind of freezing responses, as we have this inhibitory activity. It could be related to a kind of analgesic effect, or it could have a relationship with kind of preparation of or reflexes like a withdrawal effect. Actually, as you suggested, to move more nearby the body. And yeah, this is a good point. And actually, the trouble is with TMS that we wanted to stick with the FDI measure, and to go more proximal could be difficult by using just a single hotspot for the simulation. So we tried to find a good balance by having a more distal and a more proximal muscle, and we kind of manipulated the position of the shock according to this. The fact that in the second experiment, when we moved the shock more distal, we had kind of a different modulation in the more proximal MEPs, the MEPs from the more proximal muscle, suggest that possibly also a kind of reflex response could be involved here, but we actually did not measure these things. So they kept their hands on the table, they could not move, they were not required to move, they didn't move actually. So we cannot actually know, but something happened. So the position of the shock somehow influenced our results here, and this is a thing that should be considered also in future studies. The other aspect you asked was the temporal thing. Yeah. So here, yeah, we use a small lag, but actually the temporal issue is a very relevant question. In fact, Daniela is going to talk about it in more detail. Starting from this kind of experiment, we thought about whether this timing had a role in this inhibitory modulation that we found, and we actually manipulated in a following experiment that she is going to present. So this is a great question. And here, of course, the timing was always the same for all type of stimuli. So it's the prediction of the effect of the outcome of the stimulus that actually influenced our results, and not just timing in general, I can say. Okay, thank you.
Any other questions?